24 hours to learn it. How do you feel about that? Heat of vaporization is not the same thing as vapor pressure. Vapor pressure is how much evaporates. Heat of vaporization is how hot does it have to be before it evaporates. So something stronger, it's going to have to be hotter to break those intermolecular forces. Tomorrow you have an open notes test on this. You'll have time today to keep working on the review, and if the quiz you want to do that. I do have to show you a lab before we take our Form B, so can you get your lab out from yesterday? It's green. It looks like this. Chromatography is actually, if you're a babysitter, this is really fun to do with your kids. All you need is a coffee filter, and since water is so polar, it has two H bonds on it. It'll separate black marker into like the entire rainbow, and it makes something cute outside, I think. Or if you do like dark colors like purple and blue, it'll separate them. So it's like a good cheap project that takes a long time because you gotta wait for it to separate. And then you can come into shades. Anyways, chromatography is the separation of a mixture using intermolecular forces. So that's how come it fits into this. The experiment that we do does not look like this, but this can show how it will separate. These are black markers. All of them are black markers. Separate into their separate dye molecules. The one that we did was Kool-Aid, which is a good reason not to drink Kool-Aid because of the dye molecules. But setup is right here. I used not Erlen flask, a graduate cylinder. You could use a beaker. You just got to hang it off the side. You have some kind of solvent in the bottom. I used water for the example, but the actual lab has used 5 different solvents. We'll talk about that. Put a little dot of dye, a scribble of marker, ours is Kool-Aid, on here, and then the water creeps up the paper because of the intermolecular forces, drags the dye molecules with it because of the intermolecular forces, and separates it, okay? There's 3 different phases, kind of vocabby stuff. The component mixture is what we are separating. For this lab, it was Kool-Aid. In order to give Kool-Aid its color, they throw dye molecules in it. Sugar doesn't have a color, basically it's sugar water. Okay? The stationary phase is the paper. Stationary means it doesn't move. Paper has a bunch of H bonds hanging off of it. Cellulose does. So paper is polar. It has H bonds and dipoles to it. The component mixtures are these. These are the dye molecules. The component. Kool-Aid's just a cheap way to get dye molecules. So big organics, because it's going to be big organics. When we look at big organics, we look for double bonded oxygens, we look for hydroxides, we're looking for anywhere where there's going to be a dipole. So those component mixtures have dipoles, they have H bonds. They obviously have a huge London dispersion. They're very big, okay? And the last thing is called the mobile phase. The mobile phase are the different solvents. So solvent, it just means liquid, and it's what's at the bottom of the flask. These are the mobile phase. Ran the experiment with hexane. If you look at hexane, hexane is non-polar. It would only have London dispersion. Ethanol, 2-propanol and ethanol really aren't all that different. They're about the same size and they have 1 H bond. Water has 2 H bonds, and then acetone has that dipole-dipole. Okay? So what you have to do, the first thing you have to do is describe the intermolecular forces between each of these phases. So component to stationary, component to mobile, and then stationary to mobile. Okay? You're looking at the molecules, picking out the dipoles, that kind of stuff. Then on the back, you're going to, you can come up here and look. This was water, just so we had a fresh one to look at. You can see that it's you would predict it would separate us because it has 2 H bonds, so it's the strongest. It separates it into red, yellow, and blue. The rest of them you can look up there if you want to. Explain why, and explain why hexane would not separate anything. Okay? It's going to be due Monday, but if you get it done today, you can just put it in. For B is right here. When you're done with that, you can work in the lab, or you can get ready for your test tomorrow. Yeah? Ready? Steady,